Hello everyone, how are you doing? Welcome back to 40 Days of JavaScript. Today is day 38 and we are going to talk about memory and memory management in JavaScript. A bit advanced topic. However, you won't feel this topic is advanced at all if you have been following the 40 Days of JavaScript all the way. Because most of the things that we are going to touch base or going to discuss, we have already discussed part of some of the other sessions. So let's get started with what we are planning to cover in today's session. What are we going to learn today? We are going to learn about JavaScript memory management, like how JavaScript manages variable, objects, function, etc. in memory. And then we're going to talk about what is reachability theory, a very important thing to know, at least theoretically, like what is happening behind the scene, what is happening under the hood, even if you don't have to really do specially coding wise as a developer. But it is also good to know how JavaScript is taking care of things. And then you will slowly understand what is garbage collection. And then you will know that, okay, garbage collection in JavaScript is quite automatic, but still, as a developer, you need to do a few things to make sure that the garbage collection is not getting blocked or garbage collection is not behaving or getting misleaded because of the way that you are putting your code across, right? So we are going to talk about all of them, and then I'm going to refer to you a few resources that you can look into to go more in depth in case you are more interested on this topic. All right, so let's get started with JavaScript memory management. Do you remember this image? If you remember this image, then guys, let me know in the comment right now that you remember, you recollect seeing this image as part of 40 days of JavaScript. If you haven't, I would recommend that you go to the session where we discussed about execution context. This particular image is coming from there. On that time, we discussed about two things. One was stack and another was heap, if you remember, and how stack and heap were related in that particular video. Now, as I told that this session will be more about recap and going a little bit deeper than what we have discussed about JavaScript memory management before. So let's talk about these two primary things first. What is stack? What is heap? And how these two things play their role together in case of managing memory in JavaScript. JavaScript's memory management primarily uses two distinct areas. One we call as stack. Let's imagine this is the one, and then another is heap. Now the question comes always like what goes where and why. Let's talk about the stack first. The stack is primarily used for static memory allocation. You have to remember this. Stack is primarily used for static memory allocation, meaning you will know that what is the size of the data that you're storing in the stack in the compilation time itself. Means well before your runtime of your program, you will know what is the size of that particular data that you are storing in the stack. That is the purpose of the stack. It's always like limited. On the contrary, all the dynamic things that happens in the runtime, those things will be getting stored in the heap. You can think in this way. Now, if I say that in stack, you store the static things whose size you would know at the compile time itself, I think we're talking about something like a primitive data types. Again, primitive, non-primitive are the very basic things we have already discussed before. What are those primitive data types that exist in JavaScript? There is number, there is string, there is boolean, there is null, there is undefined. All these things are stored in stack. Additionally, stack store one more thing. What is that? When we are talking about the objects in JavaScript, we have learned that there is something called references. One is reference, and then taking the reference, we can go somewhere where the actual value of the object getting stored. The actual object and its memory allocation always happen inside heap. So if you consider this one as heap memory, there will be some discrete memory location. Think about this particular memory location over here, which will have a memory address. Inside this memory, you can store JavaScript objects. What are the JavaScript objects? We know object is a key value pair, there will be a curly braces, but apart from that, in JavaScript, arrays, functions, everything underlying we know those are objects. So everything gets stored in the heap. Now for each of those objects in heap, there will be memory allocated, and that memory will have a distinct memory address, so that using that memory address, anyone can reach to that particular location and can see what object is getting stored over there. Now this particular reference, that the address of that particular memory, where exactly this object is getting stored, that information also gets stored in the stack itself. So you can think about stack is your post office, right? In a post office, your letter will be there. On the letter, your address will be there. Now a postmaster will look into that address, and then only that postmaster can reach to your home to deliver the letter. So the actual home where you resides is there in the heap, but your address using which the postmaster is reaching your home, you can think that address is there in the stack. Okay, so what are the things the stack can have? Again, stack can have all the primitive data types, number, string, boolean, null, undefined. Those are all stored in the stack. Additionally, reference to objects and functions which are stored in the heap, that also kept in the stack. So stack will have the reference where in heap memory an object or a function is stored, that particular reference. So this is about stack. By nature, by data structure, we know that stack is what? Stack is a LIFO. LIFO means last in, first out. The element that gets inside the stack last will come out first. It's a very simple data structure. Apart from storing these primitives and the references, there is another great usage of stack that we have seen in the function session, that it can keep track of function executions, right? So whenever JavaScript will execute a function, it will push that function inside the stack, and once the execution is over, it will take that function out of the stack. That's why we also call it as call stack. We have learned about that. So this is another usefulness of stack that you have to keep in mind. Now imagine if an interviewer asks you a question, why the stack data structure used in JavaScript and where it is get used? You know the answers. Stack data structure is used in JavaScript for memory management. There are various ways stack data structure helps in JavaScript memory management. One is definitive for storing the primitive data types. You will give the example of primitive data types. Then there is something called heap in JavaScript. Again, it used for memory management. There, JavaScript stores the functions, objects, and etc. Now, as it is a discrete memory, there are different memory locations where these objects, functions get stored. The location where it is getting stored, it needs a reference so that programmatically we can reach to that particular location and get the value out. So that reference, the address, that is also gets stored in stack. Apart from that, stack is a great data structure which gets used in JavaScript for the function execution. Whenever the function gets executed, it pushed inside the stack. Once the execution is over, it comes out of the stack. So why the stack is also called call stack. And as it is kind of very simple data structure, sequential in nature, accessing data in stack will be much faster. It's a kind of direct access, static access. So this is what you can explain in your interview as well. Now let's move towards heap. While stack is static, heap is dynamic. Where exactly dynamic? In terms of the memory location. Because the data that gets stored inside heap, you may not know what will be the size of the data in the compilation time itself. That might change on runtime. And that is where managing the memory comes very handy. If you are storing in the memory which might change in the runtime dynamically, you need something dynamically, automatically to control that memory and manage that memory better. Because in your programming environment, there will be some limitation of memory for sure. Even if you have huge memory, still it's not enough memory. It's like money. Even if you have lot of money is also not enough money, right? You want your program's memory to be controlled. And that is where JavaScript also does it using something called garbage collection. Heap stores objects and function. That's what we call as a non-primitive data type. Arrays, function, objects, all this thing gets stored in the heap. Now a bigger question is, who manages this memory? Who manages this memory in stack? Who manages this memory in heap? Do we need to write our program in such a way that this memory management happen efficiently? These are the questions that can come in your mind. Now let me give you some answer before we take a little more deep dive into this subject. JavaScript memory management is primarily handled automatically by the JavaScript engine itself. JavaScript engine utilizes a process called garbage collection. It means that as a developer, you generally don't have to write code for managing memory directly. That's what you do in a programming language like C. However, you need to understand the way that you write your code, the way that you deal with your code, that might influence how garbage collector might behave at the end of the day. We're going to see some of the examples towards the end. Now to talk about some of the key concepts about garbage collection and the memory management is, garbage collection is automatic. It's automatic memory management. It means JavaScript engine automatically allocate memories for variable, objects, functions. We have learned that. And then also have the capability to free those memory up when those are not used. Now, please note down here the question, interview question, how garbage collector would know that this particular memory is not in use. What exactly garbage collector uses to be aware of that fact? We're coming to that. There is a concept of reachability come into picture. What is reachability? In plain English, reachability means the ability to reach someone. Think of a case that you are somewhere and from your home, maybe your mom, dad, or any of your relatives want to reach out to you. One of the way that they would do is probably pick up the phone and give you a call. Now, if you are in the network zone, you are reachable, right? You are connected over the phone and the relative would be able to talk to you. You will be able to respond. But at times, what happens is like some areas, the network coverage might not be good and the family is not able to connect to you for the time being and you become unreachable on that particular time. Similarly, if we want to put that analogy in JavaScript, its variables, its object, there will be cases where we would consider that a function, variable, parameter is reachable. What are those cases? When a function executes, for example, let's talk about function, some function, and inside that we have some variable called a. We are doing return a plus 30. So when the function is getting executed, these local variables a, you're computing another variables using a, all these variables are reachable. Reachable means they are active, they are actively working when this function is getting executed. It means that if a variable is reachable, this variable is contributing to your programming. That means don't do anything with those variable as a garbage collector, because garbage collector is like a sweeper. A sweeper is seeing any kind of dirt that is lying on the road is going to clean it up immediately. Similarly, garbage collector is also continuously looking for, is there any memory that is lying there which is not being used? I'm going to sweep it away so that it can be used later by the programming itself. Correct? Now, when the function is getting executed, every local variable of that function, or if the function is taking a parameter, all the parameters, everything will considered as reachable. Then if this function calling some other function and this some other function say over here. Now if this is the case, we are actually constructing a chain, isn't it? Some function is getting executed, but some function also calls some other function, and inside that I have another variable whose value may be an object. In this case also, the chained functions, all the local variables, chained functions, all the parameters are reachable. That means we're saying garbage collector, hey garbage collector, when my function is getting executed, don't touch my parameter, don't touch my local variables. Check, is there other functions also going to get called or going to get executed inside me? Treat them similar way. Don't claim their local variables. If they have parameters, don't do. So functions in the chain, the current calls, the nested calls, their local variables, their parameters should not be claimed. The third thing are the global variable, which we already discouraged that don't create much. If you have to create, let's say, some global variable, this is also not going to claimed until unless we do something special for this one. Apart from this, there will be some other internal variables which are also not going to be touched by garbage collector for the garbage collection purpose. So all these things that we just now explained, that these are the reachable things, consider that these are called as roots, and you can think it like a tree structure. So there is a root. From the root, there are nodes. You can consider it like a tree structure, that there is something called root. And from the root, whatever is reachable, the reachability I'm showing it using this arrow, that what is reachable, garbage collector is going to mark them as these things are reachable. And if something is not reachable from the root, mark them as not reachable. Garbage collector will keep looking for it in cycles, and in some cycle it is going to free it up so that that memory location can be used later point in time. Now if you are able to visualize this, let us take a few examples so that with that examples we can connect this reachability and you can understand things much more clearly. Here I have created an employee object, and there is a property and value. Property is salary, there is a value, and this is assigned to this variable called employee. And you are seeing this particular employee object is created globally, it's not inside any function, isn't it? Now if you want to draw the reachability tree, there will be something called global, and from global we have another object. The object is salary colon a particular value, and we would name this one as our employee, right? That is the variable that we have created. So now we have a global employee variable, and that employee variable is referring to an object whose value is a key and value, which is like salary, and the value is a particular number. This particular arrow that we are talking over here is nothing but, this is what we have been saying, like in case of objects, like objects arrays function, there is something called reference, and previously we have drawn the line from the stack to heap. In there is a reference from stack to a particular memory location in the heap, right? So similar thing, but in a tree structure that we're showing, because we want to talk about the reachability. Now, as long as this reference exists, it means that this particular object is reachable, and garbage collector is not going to do anything with it. Garbage collector is not going to claim its memory back, because garbage collector thinks that this particular guy isn't used. Now, if any point in time, if this object is not being used, there are different ways to identify. So one of the things that we're going to talk about is the reachability. In case in your code, some point in time, if you are making this employee equals to null, on that time you are actually breaking this reference. Now, as you are breaking this reference, it now you're seeing there is no connection from your root to this particular object. Now, what happened? This particular object is called as unreachable. There is no way that someone can access this particular object because reference itself we have deleted. Now garbage collector will come into picture and it will say, oh, this is something that I can actually claim. It means it is going to free up the memory location where this particular object was residing. Okay, so this is how the reachability works. This is a very simple example. Some of the use cases could be much more complex. There is something called a cyclic reference. Let's talk about that and let's try to understand how garbage collector and the reachability algorithm will work in case of a cyclic dependency or the cyclic way of referencing in JavaScript. Take a look into this code snippet on screen. So here we are creating cyclic references. Okay, let's understand this. There is a function called create cycle which takes two objects, object A and object B. What we're doing over here, we are creating a property or an attribute of object A, say object A.ref reference, assigning the value object B to it. And for object B, again, we are creating the same name property, though this ref and this ref are different. This ref belong to object A, this ref belong to object B. You can give any name. You can give ref A, ref B also. Okay. So object B dot reference now the value is object A. So this is creating some kind of cyclic references. Object A has a ref reference attribute whose value is object B. Object B also having a ref reference attribute whose value is object A. Now finally we are returning an object with a property A whose value is object A and a property B whose value is object B. So that every time we call this create cycle function by passing two different objects, we can create these cyclic references and return a new object. That's the whole objective. That's what we are doing over here. We're creating a cycle. So it returns a cycle, and what we're passing two objects, two distinguished objects. First one is having salary property with value 100. Second one is having salary property with value 200. Now let's see if we run this, does it really create a cyclic dependency or not? So let me just copy this from here and I'm going to execute it from here. Then this cycle, I will do a print of its value. Of course, cycle is nothing but this particular object which is having two property. One is A and B. We can see A and B. A's value is object A. This is this particular object. B's value is object B, which is like this particular object, which is very straightforward. But the fun is in expanding this and try to see what are these objects. So if I expand A, I see, oh, A is salary 100 and there is something called ref. How? Because the salary 100 I have passed, object A has come. In that, a new property ref got added, whose value is object B. Object B is salary 200. That's why salary 100, and there is a new property now ref, whose value will be salary 200, this particular object. But with the salary 200, this object B, I have also created another ref and assigned the value of object A. So you see object A is salary 2. So if I expand this A now, I am seeing, wow, salary 200, ref now contain salary 200 and again another ref. Now if I just expand this one, wow, I see this is contain another ref. So it's keep going. Do you see? It's keep going in the cycle. Once 100, another 200. Once 100, another 200. 100, 200. So this is where we have created a cyclic references. Now we told that the reachability works in a way that if there is a reference exist, that means garbage collector has no way to claim the memory from there. That means that memory will be hanging there probably forever. Is it the case? Now this is where the point also comes, like, as a developer, you have to make sure that you help in freeing up memory programmatically, even with not doing something directly with the memory collection management. How? Let us first understand this code and its reachability tree visually. Then we'll say, like, what are the possible ways we can write our code or do something in our code so that we can tell garbage collector, hey, here is a possibility that you can do some garbage collection because I'm not using this part of my references versus that part of my references, right? Let's see that. Here, what you see on the screen, the left side is the exactly same code that we have seen just now. The right side is the representation of the reachability tree. This is how it works. So here I got the root. From root, I have a reference cycle to an object. What is cycle? This is the cycle. This is the reference we're talking about. This is the variable. And this refer to an object, which is nothing but this particular object, which is returned by calling this create cycle function. This is the object. Now, inside this object, we found there are two things happen. One is A, another is B, right? This object, if create cycle is returning this one, inside this, there will be one A and one B property. So A, again, having a value of another object. That means A is a reference. So this is the reference which point to another one object, which is nothing but salary 100. Similarly, this B is over here, which is pointing to object B. Object B is nothing but the second parameter, which is like salary 200. So here salary 200, another object. And interestingly, object A is having an ref which point to object B. This is what it is. And object B is having another ref which point to object A, which is this one. So this is where we have a cyclic references over here, here to here, here to here. Now in this case, the objects are reachable. That means garbage collector is not going to claim the memory from any of this object. Now what if in some cases you think that, okay, certain references are not required. With program, you just delete this particular reference. Do you think now this particular object become unreachable? What do you think? No, in this case also it is not unreachable, right? You can come from root in this path, going like this, and then coming like this. So this is still reachable. So if you want this object, this one, and its memory location to be claimed, you have to make it unreachable. In that case, what you have to do additionally is you also have to take out this reference from here. Now, is there a way to reach to this object? Think of it. Can you reach it? In this way, you cannot reach. You can only reach till here. In this way, you can reach only till here because this arrow is also gone. So it means now garbage collector can come and see, oh, this particular object is no more reachable. Let's claim the memory for it and let's utilize this memory for something else. Correct? So this is how the things are, guys. This is how things happen. Now you will ask, like I just now said, okay, programmatically you can do something to make this object unreachable. You won't make this object unreachable just like that. If it is required by your programming needs, for example, based on your use case, you might feel this reference is not required. In that case, you would have written the code like deleting the reference as delete cycle. So if you did delete cycle dot, this particular reference would have gone, or you would have done delete cycle dot b dot ref. In that case, cycle dot b dot particular ref, that particular reference was also gone. If based on your use case you had to delete these references, only in that case this particular object become unreachable and then garbage collector can act on it. But if your use case doesn't demand that this is something that you have to do, garbage collection doesn't come into picture at all. Maybe later point in time, like the cycle object itself is not required anymore and you do cycle equals to null. In that case, what happens? This entire thing become unreachable because you have done cycle equals to null. So from root, this entire thing is not reachable. Now garbage collection can come and can take away this entire thing. That means the memory location for this, everything. Even if you had a connection from this object to this, connection from this to this, because this entire block is not reachable from your root. You understanding? So the reachability always matters from the root. If the reachability is not there from the root, even if internally you have the full reachability, it is just going to get claimed off. Your garbage collector will come and claim the memory for it. I hope this is crystal clear. Let's take one more simplistic example now. So guys, question to you. I have a variable called DPT, a reference that point to an object which is having a key value pair, name finance. Then I have assigned this DPT to another variable called department. Question to you. Now, how many references are there? how many objects are there in the memory, and what happened to garbage collection if you want to draw a reachability diagram. Let's do that. Let's first do this global thing. This is the root. From the root, now how many references are there? Of course, one reference is DEPT, and that is referring to this particular object named finance. So I'm going to put this object over here, and that object is having this key value pair name and finance. Great. And there is a reference now to this. The reference name is, of course, DEPT. We know that. Now in this line, this is fine. This is great. This is very simple. And this object is definitely reachable from this root. So garbage collector won't come and claim it, right? Unless we make DEPT equals to null. We have seen that example. Now we have also assigned now DEPT to another variable called department. We have learned from our object session that if we do certain things, it means that we are creating another reference to the same object. Correct? That means we are now creating another reference whose name is department, and it is exactly pointing to the same object. DEPT equals to null. Do you think garbage collector will come and free up the memory for this particular object? Is it going to happen? When you do DEPT equals to null, this reference has to go, of course. But is this object still reachable? Yes, it is reachable because department is still referencing it. And by our reachability algorithm and the rule, JavaScript's garbage collector is not going to free up this memory because it is still reachable. So these are again some of the tricky questions, my friends, that if after this DEPT become null, is this particular object is going to get garbage collected? No, because there is a reference exist. So if you think from the reachability diagram wise, if you think from those point of view, answering some of this question will be real cakewalk for you, isn't it? Now you understand these things quite clearly, and you will be able to answer these questions quite convincingly in your interviews. So these are the things as a JavaScript developer you have got to know from your interview perspective, where the tricky question will come, whether this particular memory will be freed up for this object or not, what happened when the cyclic references happen, what happened when there are two references, more than two references exist, and you're making one of the reference null, the memory will be freed. All these things are the tricky questions. Now you'll be able to answer them very, very easily. Reachability is just the first step for JavaScript's garbage collector's internal algorithms. JavaScript uses algorithms like mark and sweep. The young generation, old generations, there are varieties of aspects that involve for garbage collector to work efficiently. All of this implementation based on the environment in which JavaScript is running. For example, your browser or Node.js. One of the implementation would be V8 engine that got its own implementation on how it handles the garbage collection. The other JavaScript engine might differ a bit here and there in terms of how it has written its algorithm for managing and maintaining the garbage collection. Let's talk about some of the common things. For example, mark and sweep algorithm. So at a very high level, how these things is going to work, you already know what is reachability. Now, JavaScript garbage collector works in cycle. In every cycle, it is going to see whether a particular object is reachable from the root or not. If the object is reachable from the root, is going to mark them as reachable. So this particular object is reachable, reference from here, so I can mark it as reachable. I can mark this one as reachable. I can mark it as reachable. I can mark it as reachable. I can mark it as reachable. How about this guy? This guy is not reachable from the root, so I cannot mark this as reachable. This one is reachable from this one, but again this one is not reachable from the root, so I cannot mark it as reachable. This one is reachable from this one is reachable from this one, but again this one is not reachable from the root, so I cannot mark it as reachable. Now as I am not able to mark this one as reachable, this one as reachable, this one is reachable, what I can do as garbage collector is I am going to free up the memory for this. So I have marked first, and then I'm sweeping of the memory that is not reachable with all the reachability algorithm that we have just now defined. So I can just delete them out, right? So this is how at a very high level how mark and sweep exist, mark and sweep works. I would leave you with a few more references where you can learn things much more deeper. One of the great references, optimizing V8 memory consumption. So there is an article, you can take a look into it, and from this article there will be few other links that you might be interested in looking into. Here is a talk, and you must look into this particular YouTube video if you want to understand how garbage collector works in V8. This is a 20 minutes video that's going to give you a good overview visually how things work. So if you're interested to do a deep dive, I would definitely recommend to go through this video, and you can also go through the same article. And the last thing would be the memory management article or the memory management doc that is there in the MDN web docs. You can also take a look many of the things that you have find here which we have already discussed, but it will be a good recap. All these links are there in the description of this video. Please go ahead and check it out. Don't forget to do the task that I have given. To get the task, come to github.com/tapaScript. You can follow this organization. I keep posting a lot of great repositories over here, and here you can find 40 days of JavaScript. Please feel free to give a star to this repo if you find it useful. And then just like all these days are here, you will find a day 38. And once you come inside that, you will find a task.md file. Inside that, there are few tasks there for you based on whatever you have learned in this session. And once you do this task, please come to tapaScript Discord. The link to join the Discord community is also in the description of this video. And over here, you will find 40 days of JavaScript. You can discuss about your task over here, like how many of the people are discussing things over here. And time to time, I keep posting few things. Also, if you're doing a task, please post about the task assignments over here. Awesome to see that many folks are doing this already. Please join them if you're not doing it already. With this, we come to the session of the day 38, and then two more sessions are left, 39 and 40. Today's session I kept it at very high level, more with the easily understandable language. I hope you like it. In that case, please post a like. Please comment saying that what you understood, whether it was useful to you. And if you have not subscribed to tapaScript, please do that, because I bring a lot of great content, a lot of research out content, deep content for you. Spending a lot of time, it will be a great motivation. Next two sessions are very important, where in the session 39 we're going to talk about getting ready with JavaScript interviews. I have already released a short video giving you 6 problem statement to solve, isn't it? Like that, many other problem statement will be solving in the next video, which is session number 39, and give you some tips and tricks to get ready and crack your JavaScript based interviews. And then the final session, day 40, where we'll be doing a project together and we'll finish this 40 days of JavaScript initiative, which is very, very close to my heart, and great to know that many of you are already liking it. All right, so stay tuned. We'll be coming back very soon with day 39.